Hi everyone, welcome to this video on software. In this lesson, we'll be exploring some concepts that are crucial for understanding how different types of software work and their applications. By the end of this video, you should be able to identify the differences between system software and application software. You should be able to explain the concept of utility programs with examples and justify the selection of appropriate software for specific tasks. You should be able to compare open source and proprietary software. These objectives will help guide our discussion and help you grasp the essential aspects of software in computing. Software can be broadly categorized into different types, each serving unique purposes and functions. Understanding these categories is essential as it helps us choose the right tools for our needs. The main categories of software are system software and application software. System software is designed to manage the system resources and provide a platform for application software to run. Application software, on the other hand, is designed to help users perform specific tasks. Let's look a little deeper into these categories to understand their roles and importance. System software is the backbone of any computer. It is essential for managing hardware and running applications. Without system software, our computers would not be able to function. System software includes several key components. Firstly, we have operating systems. These are the core software that manage hardware and software resources. Examples of operating systems include Windows, Mac OS, and Linux. They provide a user interface, manage memory, handle interrupts, and schedule processor time. Next, we have utility programs. These tools that optimize system performance and handle maintenance tasks. Examples include disk defragmenters, automatic backup tools, and virus checkers. Libraries are another crucial component of system software. They are collections of pre-written code that can be used by programs to perform common tasks. This saves developers time and effort as they do not have to write code from scratch for every function that they wish to program. Finally, we have translators. These convert code from one programming language to another. Examples of translators include compilers and interpreters. They are essential for running programs written in different programming languages on a computer. We have previously discussed operating systems, but let's revisit their primary functions to refresh our memory. Operating systems perform several essential tasks that are crucial for the smooth operation of a computer system. The operating system provides a user interface which allows users to interact with the computer. This can be through graphical interfaces, like the ones we see in Windows and Mac OS, or command lines, like those in Linux. The user interface is what makes it possible for us to give commands to the computer. Memory management is another critical function of the operating system. It allocates and manages the computer's memory resources, ensuring efficient use of RAM. This is important because it allows multiple programs to run simultaneously without interfering with each other. Interrupt handling is also managed by the operating system. It deals with interruptions from hardware or software to ensure smooth operation. For example, when you press a key on your keyboard, the operating system handles the interrupt and processes the input. Processor scheduling is another vital function. It manages CPU time to allow multiple tasks to run simultaneously, enabling multitasking. This means that you can listen to music, browse the internet, and work on a document all at the same time. Utility programs are essential tools that enhance the computer's performance and handle background tasks. These programs ensure that the system runs smoothly and efficiently. Let's look at some examples of utility programs and their functions. A disk defragmenter reorganizes fragmented data on a hard disk drive to improve read speeds. When files are stored on a hard drive, they become fragmented, meaning they are split across different locations. The disk defragmenter reorganizes these files into contiguous blocks, making it quicker to read them. Automatic backup tools regularly back up data to prevent loss. This is crucial for protecting important data from hardware failure or cyber attacks. Automated backups can be scheduled to occur at specific times, such as when the computer is not in use, and can be stored on portable drives, cloud storage, or local servers. Automatic updating tools keep software up to date with the latest features and security patches. For example, Windows Update can add new features or fix security vulnerabilities, protecting against hackers. Virus checkers scan storage for viruses by comparing files to known virus definitions and scanning files as they are accessed. Antivirus software uses heuristics to detect suspicious behavior, sometimes flagging harmless files as potential threats. Compression software reduces file sizes for easier storage and transfer. For example, sending a large video file via email. Some files compress well, while others do not. The compressibility of a file depends on its content. Text files, for example, often compress well because they contain repetitive patterns. In contrast, already compressed files like JPEG images or MP3 audio files do not compress much further. Large files on a magnetic hard drive can become fragmented, meaning they are split across different locations. The disk defragmenter reorganizes these files into contiguous blocks, improving read speeds. Imagine a book with its pages scattered around a library. The, the defragmenter puts the pages back in order, making it quicker to read the book. Consider files stored on a disk drive. The disk defragmenter will move files to ensure all parts of a file are contiguous. Gaps or fragmented spaces can appear on a hard drive for several reasons. When files are deleted, the space they occupied become available. New files may not fit perfectly into these spaces, leading to fragmentation. When existing When existing files are modified and grow in size, they may no longer fit in their original location. The system then splits the file across multiple locations. Installing new software or system updates can create gaps as files are written to the disk in the available spaces. The creation and deletion of temporary files during various operations can also contribute to fragmentation. These gaps can slow down the system because the read-write head of the hard drive has to move to different locations to access a single file, rather than reading it in one continuous sequence. Regular backups of data in permanent storage are crucial to prevent data loss. Businesses need backups to protect against data loss due to hardware failure or cyber attacks. Automated backups can be scheduled to occur at specific times, such as when the computer is not in use and can be stored on portable drives, cloud storage, or local servers. This ensures that the important data is always protected and can be restored in case of an emergency. This utility runs in the background, detecting and installing software updates. Windows updates, for example, can add new features or fix security vulnerabilities, protecting against hackers. Keeping software up to date is essential for maintaining the security and functionality of a computer system. Automatic updating tools ensure that the latest updates are installed without requiring user intervention. Virus checkers can scan storage for viruses by comparing files to known virus definitions and scanning files as they are accessed. Antivirus software uses heuristics to detect suspicious behavior, sometimes flagging harmless files as potential threats. This can happen due to heuristic analysis, where the software looks for patterns of behavior that are similar to known viruses. Sometimes legitimate files may exhibit similar patterns, leading to false positives. It is important to regularly update virus definitions to ensure that the antivirus software can detect the latest threats. Compression software. Compression software reduces file sizes for easier internet transfer. For example, sending a large video file via email. Some files compress well, while others do not. The compressibility of a file depends on its content. Text files, for example, often compress well because they contain repetitive patterns. On the other hand, already compressed files like JPEG images or MP3 audio files do not compress much further. Compression software is useful for saving storage space and reducing the time required to transfer files over the internet. Libraries provide pre-written routines, and translators convert code into executable form. These will be covered in topic 4. Libraries save developers' time and effort by providing reusable code for common tasks. Translators, such as compilers and interpreters, are essential for running programs written in different programming languages on a computer. Application software performs tasks for users and can be categorized into general purpose, special purpose, and bespoke software. General purpose software can be used for a variety of tasks such as word processors and spreadsheets. Special purpose software is designed for a specific task like photo editing software. Bespoke software is custom software created for a specific user or organization. Mobile apps are a form of application software that can be used for various purposes, from communication to entertainment. Off-the-shelf software is ready-made software available for purchase. Examples include Microsoft Office and Adobe Photoshop. Bespoke software, on the other hand, is custom software created for specific needs, often used by businesses to meet unique requirements. Bespoke software is tailored to the specific needs of the user, providing a more personalized solution compared to off-the-shelf software. Open source software allows anyone to access and modify its source code. Linux is an example of open source software that is free to use, with the condition that any modifications are also open source. Open source software promotes collaboration and innovation as developers can contribute to and improve the software. It also provides users with more control over the software that they use. Closed source software, also known as proprietary software, does not provide access to its source code. Users must purchase a license to use it, and there are often usage restrictions. An example of proprietary software is Microsoft Office. Unlike open source software, proprietary software is developed and maintained by a company or individual who retains exclusive control over its source code. This means that users cannot modify or distribute the software without permission. Proprietary software often comes with customer support and regular updates, but it can be more expensive and less flexible than open source alternatives. When choosing an application, several factors need to be considered to ensure it meets your needs. These factors include functionality, hardware compatibility, availability, cost, and reliability. Functionality is the most critical factor. You need to ensure that the software can perform the tasks you require. For example, if you need software for graphic design, you would not look for features like image editing, layer management. Sorry, you would look for features like image editing, layer management, and vector graphics support. Hardware compatibility is also essential. The software must be able to run on your existing hardware. For instance, high-end video editing may require a powerful computer with a fast processor, plenty of RAM, and a high-quality graphics card. Availability refers to whether the software is readily available for purchase or download. Off-the-shelf software is usually easy to obtain, while bespoke software may take time to develop and implement. Cost is another really important factor. You need to consider your budget, whether the software provides good value for money. Open source software is often free, while proprietary software may require a one-time purchase or subscription fee. Reliability is also important. The software should be well tested and free of bugs. Reading reviews and checking for regular updates can help you determine the reliability of software. Let's summarize what we've learned today. We started by identifying the differences between system software and application software. System software is essential for managing hardware and running applications, while application software performs tasks for users. We then explained the concept of utility programs with examples. Utility programs enhance the computer's performance and handle background tasks. Examples include disk defragmenters, automatic backup tools, virus checkers, and compression software. Next, we justified the selection of appropriate software for specific tasks. When choosing software, consider factors such as functionality, hardware compatibility, availability, cost, and reliability. Finally, we compared open source and proprietary software. Open source software allows anyone to access and modify its source code, promoting collaboration and innovation. Proprietary software, on the other hand, does not provide access to its source code and often comes with usage restrictions. Thanks for watching. I hope this video has helped you understand the different types of software and their uses. Don't forget to like, comment, and subscribe for more educational content. See you next time.